Okay, let's move ahead and let me ask you, and you very quickly tell me this. This pulley is going with velocity v, and the whole thing is frictionless. What do you think will be the velocity of the block? The velocity of the block. Now, in order to see this mathematically, what you should see is if the pulley goes with a distance x ahead, if the center moves with a distance x, then the rope upward and the rope downward, they both move x distance. So the total amount of rope that will be required for x displacement of the pulley will be 2 into x. And that displacement, that amount of rope has to come with the forward displacement of this block. Suppose this pulley goes x distance forward and this block goes y distance forward, then the obvious relation would be y has to be equal to 2 into x, because the length of the string is constant. And you just differentiate this. Dy by dt is equal to 2 into dx by dt. So dy by dt is the velocity of the block, has to be 2 times the velocity of pulley. Because this displacement, the relation between displacement is twice, and the displacement has to happen in the same given time. So of course the velocity will also have the same relation. So you have to use a little bit of your visualization here. It's a simple case, so it was easy. Let's see this one. This end is going with velocity v. Now you have been asked what is the velocity with which the mass will be going up. It's still a very simple case, and you have to use the same logic as we used in the previous case. This point is going down with velocity v. If this is going up with velocity u, what is the relation between v and u? So if this pulley goes up by a distance x, then the total string that will be loosed will be 2 into x on both sides. And if this goes down a distance y, then the total string that will be required will be y. So 2 into x should be equal to y. And from here you can see that the velocity of this pulley will be half the velocity of dx upon dt will be equal to half dy upon dt. So the velocity of pulley, which is u, will be v upon 2. Okay, let's increase the level of complexity. Okay, this is A and this is B. B is moving with velocity v. Now the question is, what is the relative velocity of A with respect to B? What is v AB? Relative velocity of A with respect to B. That is what you have been asked. And this is a problem that you should really be able to solve on your own, and you should get the answer and feel proud about yourself. So here is a chance. Okay, now suppose this block A moves x distance ahead. Then the amount of string that will be loosed will be 2 into x. And if this block has to go a y distance ahead, then the amount of a string that will be required will be, this point will be moving y, this point will be moving y ahead. To go this point to go ahead, y distance, y length of a string is required, and for this point to go ahead y distance, 2y length of a string is required. Y for this side and y for this side. So if this is moving a distance y, then 3y length of a string is required. If this is moving a distance x, then 2x length of the distance, 2x length of the string will be loosed. So these two should be equal because a string is remaining taut all the time. So this should be the relation between the displacement of A and B. So the velocity of A dx upon dt would be equal to 3 by 2 times of dy upon dt. Fine. So the velocity u will be 3 by 2 times of v. So if it is going with v velocity, this is going with 3 by 2 into v velocity. So the velocity of A with respect to B, we know, is velocity of A minus velocity of B. That is 3 by 2v minus v. So the velocity is v by 2. Okay? You got v by 2? Very good. If you got this correct, then you should also get the next one correct. Okay, so here it is for you. It's given that the velocity with which this block is moving, A block is moving, is 1 meter per second. So the velocity of block B, what is the velocity of B? Now you should be able to generate speed in you. Now you know the concept, now you have to develop speed. So let's see, if this block A is moving x distance ahead, let's see the amount of string that will be loosed. X from here, x from here, and x from here. 3x of the string will be loosed. Right? So, and if this has to go y distance down, then how much of the string is required? Only y length of the string is required.